We are now in the second part of this chapter, which is inverse Laplace transform. Okay, so before this, in the first part, you were given the function ft, you perform the Laplace to the ft, and then you get the answer in the form of fs. Now the other way around, you were given the expression, the transform fs. Okay, you need to perform the inverse to the fs to get the answer in the form of ft. Okay, for example, before this, you find the Laplace to the exponent 2t, for example. You map to the table and then you'll see the answer is 1 over s minus 2. Now, in this part, you were given the 1 over s minus 2. So, you perform the inverse to the 1 over s minus 2. You refer to the table, then you will see the answer is exponent 2t. Okay? So, if we map to the table, if we see the table, okay, so now you were given the right hand side of the table. You were given the expression on the right hand side of the table, and then you need to find the answer, the original expression in the form of ft. Okay, but in the inverse transform, the expression, okay, that you have normally is not quite straightforward. It is not clearly can be mapped to the table. So it means that you most unlikely you will be given, for example, s over s square plus 3 square, for example. Okay, so if you were given in that form, then okay, obviously you know the answer is cos 3t. Okay, but normally it is not given as direct as that form. Okay, so it means that in the inverse transform, we need to manipulate. Okay, we need to manipulate the expression of fs first. Okay, so that we have the expression that is similar to the table, and then we can perform the inverse transform. Okay, so that's normally the tricky part to the student. Okay, cannot be able, not be able to manipulate the expression. Okay, and then in the inverse Laplace transform, all of the previous properties that we have seen in the first part, okay, are changed accordingly. Okay, for the inverse. So it means, for example, if you want to find the inverse to the uh, 3 over s minus 2, for example. Okay, so by the linearity property, you can write this one to be 3 inverse of 1 over s minus 2, and then the answer would be 3 exponent 2t. Okay, so this is one of the example of using the linearity property. Okay, so the rest of the properties here follows accordingly for the inverse. Okay, so at the end of the video, okay, hopefully you can get the answer to this. What is the inverse to the 1? Okay, now we are going to look at example 17. Okay, so we have three simple problem here for the inverse. Okay, so let's see the first one. So the first one, you want to find the inverse to the 4 over s square plus 9. Okay, so first of all, we need to refer to the table so that we can see which one that we should map. Okay, so if you refer to the table here, you look at the right hand side of the table. Okay, so we have 4 over s square plus 9. Okay, so at the top you have constant, at the denominator you have s square plus something. Okay, so the most similar form is this guy here. So at the top you have a, okay, so at the bottom you have s square plus a square. Okay, so for this one, meaning that you need to map to the inverse to the a over s square plus a square, and then the answer is supposed to be in the form of sine. Okay, so you know, you get the hint, your answer somehow supposed to be sine. Okay, but you don't know yet sine okay, what is the value of your a, okay, maybe you have constant in the front and so on. Okay, so now by mapping, and then okay, we can write, so therefore this one is now can be written in the form of s square plus, so 9 is actually 3 square. So if we map to what we have here, so at the top it's supposed to be a, it's supposed to be tally with your 3 here. So at the top we should have 3. Okay, but if we stop there, so it means that we already change the expression that we have originally. Okay, so originally we have 4 over s square plus 9. Okay, so to get back the 4, so it means we need to multiply the expression that we have here with a 4 over 3. So if we cancel out, you can see if you cancel out 3 and 3, you will get back the original expression. Okay, but you are not going to cancel out. Okay, because by doing that you will get the original expression. Okay, so just leave at in that form. Okay, so by the linearity property, so 4 over 3 is a constant, so you can put aside 4 over 3, and then inside the inverse you have 3 over s squared plus 3 squared. So now you have exactly the same form that you have in the table. So now you can write, so this is supposed to be 4 over 3 sine AT. So your A here is 3. So this is, okay, now for B, um, for the B, we have, what's the expression? The Fs is 1 over s power of 5. So you have Fs equals 1 over s power of 5. So here we want to find the inverse to the 1 over s power of 5. Okay, so if we map to the table, okay, you have the denominator s power of 5. Okay, so if you refer to the right hand side here, the most similar expression is this one. Okay, s and plus 1. So you can see the rest, okay, the rest of the expression, you don't have s power of something. Okay, so for example, this is s power of a, s square plus a square, and so on. So the most similar is this guy here. Okay, so for this one, we map to the n factorial over sn plus 1. Okay, but first we need to manipulate the expression, okay, so that we have exactly the same expression as we have in the table. So s power of 5, if we map to what we have in the table, so 5 is actually comes from 4 plus 1. So your n is actually 4. So at the top, it's supposed to be n factorial. So it is 4 factorial. Okay, but now, okay, you have changed the original expression, which is 1 over s power of 5. Okay, so it means that this one need to be multiplied with the 1 over 4 factorial. Okay, so the same justification as before, 1 over 4 factorial can be put aside, so that in the inverse we have 4 factorial over s4 plus 1. So now the answer is, okay, 1 over 4 factorial is 1 over 24. Okay, so the inverse to 4 factorial over s power of 5 is t power of n. So if you refer here, it is t power of n. So you have t power of 4. Alright. Okay, so for C, you were given Fs equals 6 over s minus 4, s minus 1 power of 4. So if we refer to the table, okay, you have something like this, but not quite. Okay, so you have s minus a, okay, but your term has the power s minus 1 power of 4. So if you don't have the power of 4, then you should map to this one. Okay, but since you have s minus 1 power of 4, so it cannot be this one. Okay, and of course not this one. Okay, not this one, not this one, not this one. So the most similar expression is this guy here. Okay, so fs minus a means the function in the form of s minus something. Okay, so exactly that we have here. So this one is actually mapped to the inverse to the fs minus a. Alright, so if we can write, therefore, the inverse to the 6 over s minus 1 power of 4 is basically equals to the inverse of f s minus 1. Okay, so we have s minus a, our a is 1 in this case. Okay, and then we know the answer supposed to be in the form of exponent at. So a is 1, so at ft. Okay, so our task is to get this. What is the ft? All right. Okay, so again, by mapping this one to this, we know that our a is 1. Okay, and fs minus 1 is 6 over s minus 1 power of 4. So what we want to have is ft, because okay, from here we want to get the ft, and by the Laplace transform we know that we can get the ft if we take the inverse to the fs. Okay, so you have fs minus 1, but you only want fs. So it means you cover up the negative 1 here. Okay, so at the right hand side, also you remove the minus 1. So fs is 6 over s power of 4 only. Okay, so therefore our ft is the inverse to the fs, which is the inverse to the 6 over s power of 4. And then by the table, one more time, we need to map which one is the most similar expression. So again, one more time, similar to the problem in B. So this is actually comes from as 3 plus 1. Okay, so basically you map to this one again. Okay, so at the top it should be 3 factorial. So 3 factorial is 6, 3 times 2. So for this example, you don't have to manipulate. You don't have to multiply with something because 3 factorial is 6. Okay, so it is the exactly as you have you have here. So 6 over s power of 4. So automatically this is by the table, this is t power of n, where our n is 3. So this is t power of 3. But our final answer supposed to be in this form. So therefore, what we want to find the inverse to the 6 over s minus 1 power of 4 is now equals exponent t times ft, which is t power of 3. That's it. Okay, example 18. Again, this function here need to be seen as expression in the form of s minus something. Okay, because you have the bracket square here. So if you don't have minus 2, if you don't have minus 2 here, then you will map to most likely this one. Okay, the cos at. But since you have s minus something, okay, s minus 2 square plus 9. Okay, so the whole expression in the bracket here need to be seen as a function f in the form of s minus 2. Okay, so it means for problem A here, we need to map to f s minus a. Alright, so we can write that expression is mapped to the inverse of f s minus a. Okay, where our a in this case is 2 because our function is s minus 2 something. Okay, so a equals 2, and then our f s minus 2 is the whole thing that you have in the bracket, which is 2 over s minus 2 square plus 9. Okay, so by the table, we know that our answer is supposed to be in this form, exponent ATFT. Okay, so we can write here the answer is supposed to be exponent ATFT. So our task is actually to get the FT here, because the exponent thing here is not really a problem. You just substitute A equals 2. But your task is here to get the FT. Okay, so FT is the inverse to the FS. Okay, so since we know our Fs minus 2, so therefore Fs only. Okay, so you remove the negative 2 at the left. It means you remove negative 2 at the right hand side as well. So Fs would be 2 over s squared plus 9. Alright, so therefore the FT is the inverse to the Fs, which is 2 over s squared plus 9. Okay, so again, one more time, we need to map to the table. Alright, so we have the constant at the top, 2, and the denominator is s squared plus 9. So the most similar form again is sine. Okay, because we have in this form a over s square plus a square. Okay, but a little bit of manipulation. Okay, so we have s square plus 3 square. So at the top it should be 3. Okay, but the original expression is 2 at the top. So meaning that we need to multiply with a 2 over 3. Okay, so 2 over 3 can be put aside. So if we put 2 over 3, and then the inverse to the 3 over s square plus 3 square is now sine 80. Our a is 3. So sine 3t. Okay, so go back to this, right? Because we want to get the inverse to the 2 over s minus 2 square plus 9, which is supposed to be exponent at. So exponent 2t times the ft. Ft is 2 over 3 sine 3t. Okay, to make it nicer, you can put 2 over 3 in the front. Alright, so that's for the problem A. Okay, so for problem B, you have 3 over 2s plus 5 power of 3. Okay, if we refer to the table, none of the expression on the right hand side is similar to what we have here, in the sense that, okay, if you refer to the s at the right hand side, in each expression the coefficient of s is 1. Okay, whereas in your problem you have 2s. Okay, so our first task is to manipulate the expression here. Okay, so we'll try to make the coefficient of s is 1, meaning that we need to take out the 2. Okay, so if we rewrite, so 3 over 2s plus 5 power of 3. So if we take out 2, so see, you have a big bracket here. So if we take out 2, so in the bracket we have s, but then 5 is going to be 5 over 2. So all of this, power of 3. Okay, so they are equivalent. We are not changing anything in terms of mathematics, right? So if we look further, this one can be written as 3 over, so 2 power of 3 is 8. So in the bracket, we have s plus 5 over 2 power of 3. Okay, so now s plus 5 over 2 can be seen as 3 over 8 s minus negative 5 over 2 power of 3. Okay, so now this is in the form of s minus something. S minus something power of 3. So we are actually come back to this expression in A. Okay, so it means that what we have here is mapped to the inverse to the Fs minus A. So again, the answer is supposed to be exponent AT Ft. Alright, so by mapping, okay, the expression that we have to the table, we know that our A is negative 5 over 2. Right? So our A is negative 5 over 2. And our Fs minus or plus 5 over 2 is equal to the 3 over 8 s minus or s plus 5 over 2 cube. Okay, so what we want to get again is this Ft, which comes from the inverse to the Fs. So if we want to get the Fs only, so we remove the 5 over 2. So it means that we have 3 over 8s power of 3. So here the Ft is the inverse to the 3 over 8 s power of 3. By the linearity property, this is 3 over 8 inverse of 1 over s cubed. So again, we map to the table. So 3 over 8. So we map to the table. The most similar expression is this one, s n plus 1 at the bottom. Okay, so it is, if we move a bit, okay, so this one here is mapped to the s2 plus 1. So at the top, it should be 2 factorial and factorial. But we already changed the original expression, which is 1. So here we need to multiply with a 1 over 2 factorial. So that we have 1 over 2 factorial can be put aside together with a 3 over 8. So we have 3 over 16. So the inverse to the 2 factorial over s 2 plus 1 here is t power of n. So our n is 2 in this case. So this is t power of 2. Okay, so if we go back to this expression here, so this is supposed to be our final answer. So have one more line. Okay, so I'm going to put here the answer. So the final answer is supposed to be, therefore, what we have, okay, 3 over 2s plus 5 cubed here is equal to exponent at. Our a is negative 5 over 2 t, and then our ft here is 3 over 16 t squared. So 3 over 16 t squared. Okay, write nicely. Put 3 over 16 in the front. Alright, so I hope you can write clearly on your own paper, okay, on your own notes. Okay, I'm sorry for my handwriting here, but hopefully you can follow the solution, the flow of the solution, okay, for problem B.